Welcome back to The Explainer. Today, we're talking about something pretty mind-bending. We're going to look at the tools mathematicians use, not just to solve problems, but to prove that math itself actually works.
So, how high can math actually go? I mean, really, what are its limits? To even start to answer that, we got to look at how we prove things in the first place. And more importantly, what happens when our usual methods just aren't enough.
Okay, so our journey starts on the ground floor. We're talking about a tool you might remember from school, mathematical induction. Think of it like the first few rungs on this huge ladder of proof.
All right, let's really get into it, beyond just the basics. We all learn about induction, right? It's that classic knock over one domino and they all fall idea. But here's the thing. It's got a pretty big catch, a fundamental limit.
So your standard induction is this really neat step-by-step process. You prove the first case works, then you show that if any given step works, the next one will too. And boom, you've proven it for everything in the line. But what happens when you want to ask questions about the whole system of math itself, like from inside the system? Taking it one step at a time? Well, that's just not going to cut it. You'll never get high enough on the ladder. To do that, you need something way more powerful. A totally different toolkit. We're talking about specialized gear for climbing into a world that's, well, it's beyond just finite steps. It's about tackling the infinite.
So, let's meet the big guns. I want to introduce you to 3 incredibly powerful tools that the pros, the proof theorists, use to wrestle with these enormous questions about what's really true in math.
First up, we have something called bar induction. Now think of this as induction on steroids. It's not designed for a simple straight line of dominoes. Oh no, this is for handling infinitely branching paths, kind of like exploring every single root on a gigantic, endless tree.
And that's the key difference, right? Standard induction just goes one step at a time in a nice, neat line. Bar induction? It lets you look at an infinitely complex tree of possibilities and say, yep, this property holds true no matter which path you follow, all the way down.
And look, its power is just immense. We're not going to get into the weeds with things like bar recursors right now. The big takeaway here is that this tool is so strong, it can actually be used to prove that huge, foundational parts of math, like all of classical arithmetic, are actually consistent, that they don't contradict themselves. That's a huge deal.
Okay, on to our second tool. And this one is really cool. It's called a reflection principle. And it's fascinating because it gives a mathematical system a way to talk about itself, to reflect on its own truth.
Yeah, you can almost think of it like self-awareness for a formal system. It's a rule that lets the system look at all the things it can prove and then add a new statement that basically says, hey, you know all that stuff I just proved? It's all true. It's a really powerful form of self-reference.
And what's wild is that this principle connects to all sorts of other big ideas. You can use it to actually measure how strong a system is. And get this, if you apply this principle over and over again in iterated reflection, it turns out to be the exact same thing as another advanced tool called transfinite induction. You're starting to see all this is all one big connected web, right?
All right, our third and final tool. This one is a real game changer. It's called Omega Logic, or Omega Logic, and it completely rewrites the rulebook by dragging the concept of infinity right into the very structure of a proof.
This is a massive leap. I mean, think about it. Normal logic, the kind we use every day, only lets you have a finite number of starting assumptions, your premises. But the Omega rule, it says, nah, we can do better. It builds a bridge to the infinite. It lets you draw a conclusion from an infinite list of premises.
And when you see it laid out like this, the difference is just stark. A standard proof has, premise 1, premise 2, conclusion, nice and tidy. But with an Omega logic proof, you have premise P of 0, P of 1, P of 2. And that ... isn't just for show. It literally represents an infinite number of premises leading to one conclusion. That's something that's totally off limits in regular logic.
Okay, so we've got these 3 powerhouse tools, right? Bar induction, reflection principles, and Omega logic. They all sound pretty different, pretty separate, but, and this is the really beautiful part, it turns out they're all deeply, and I think surprisingly, connected.
This right here, this is the absolute core of what we're talking about today. These tools aren't just related. In many ways, they're the same thing. They're different faces of the exact same fundamental logical power. Bar induction? Turns out that's just a kind of reflection. That transfinite induction we mentioned? That's just repeated reflection. See? It's not 3 different ladders. It's like having a single, amazing piece of climbing gear that just has different attachments. Okay, so they're all connected. Cool. But so what? Why does that even matter? What does having this unified, super powerful toolkit actually let logicians accomplish? Well, here's the payoff. This whole interconnected web of logic, this is what lets mathematicians climb high enough on that ladder to look back down and say with certainty, yep, the foundations are solid. Arithmetic is consistent. It gives them a way to measure the raw power of entire mathematical systems. It's incredible.
All right, let's bring this all home. Let's talk about the really profound takeaway from all of this, the big idea that just ties everything together. This quote really just says it all, doesn't it? It captures the magic perfectly. Somehow, we figured out how to create these small, finite descriptions, our notations, that act like keys. And these finite keys can unlock and control the staggering power of infinite proofs. It's like holding an infinite lock in your hand and having the finite key that fits.
So when you boil it all down, these incredibly abstract tools, bar induction, reflection, omega logic, they're a bridge. They're the connection between our finite minds, which think one step at a time, and the infinite, unchanging truths of mathematics itself. And that leaves us with a pretty mind-blowing question, doesn't it? If our finite minds have found a way to reason about infinity, what are the ultimate limits of what we can know? Where does mathematical truth end? It's a question that pushes right to the edge of knowledge, and frankly, it's what makes this stuff so unbelievably cool. Thanks so much for joining me on this one.